Are we ready to start? Before we say anything at all, can I have a quick show of hands, please? Does anybody here speak Bulgarian? Okay, a few of you. You might notice that my hand didn't go up. Your English is a lot better than my Bulgarian. I'm going to try my hardest. If you don't understand us, please just say and we will help you out. But thank you so much for speaking our language. It makes my life a lot easier. Thank you also for coming along tonight. I'd also like to apologise in advance for our performance. We've all been up since about 3 o'clock this morning. We were on a really early flight. We flew over. We've been here all day. We're tired. We're going to try our hardest to entertain you and to be clever. We might not succeed. But first of all, I'd like to introduce us. So we're from NewsUK. We're working with Questers to start an office here. We've been here today interviewing people, and we're interviewing more tomorrow. NewsUK, as you can see, is a company that owns a number of very famous media brands. We have radio stations. So there's a company called Wireless that owns radio stations. TalkSport is the biggest sports radio station in the UK. Virgin Radio is an up-and-coming radio station. We have other companies to do with media and video. Dow Jones does financial information. But the two sort of most famous brands that we have are The Sun in the middle there, and also The Times and The Sunday Times. So tonight we're going to talk to you about some of the things that we do. The agenda is me, first of all. So I'm head of engineering for The Times and The Sunday Times. I'm a retired developer. I haven't coded for 3 years or so, so you guys are a lot cleverer than me. But I'm going to give you my thoughts on how we build a team, what we look for, and if you want to improve your career, earn more money and get better, my thoughts on how you can do that. Then we have Andy, who's a principal engineer for The Times and Sunday Times. Super clever man. He's going to talk about how we are doing React Native and GraphQL. The title there is hard but awesome. That is how we see it. And then Jem is head of engineering for Sunsavers. He's going to be talking about ephemeral systems. Ephemeral, of course, means very, very temporary. It means up and then replaced very, very quickly and very, very fast. And we're going to talk about how we create assured delivery on our systems. So first of all, get hired, progress in your career, and earn more money. Does anybody here want to do any of that? Quick show of hands. Hand down. Okay, I think everybody does. And our approach is that, well, certainly my approach is that I absolutely have a passion for finding people who want to do all of these things. And my ambition is to have people in my team for like 2 years, for them to have done all of these things, to get a better job elsewhere and earn twice as much money. That's really my aim. And actually what happens is that if you do these things for people, they end up not leaving and they just become better and better and better. So how do we choose our team? How can you make the most of your potential? And how can you get a better job and make more money? So I say you just need to ask is all you need to do. There are 3 things, and you'll see there's a pie chart with 3 equal slices. And I break it down into activity, skill, and knowledge. And I'd like to start in reverse order. But first of all, can anyone have a guess about what might be the most important thing out of those 3? Activity, skill, and knowledge. Any hands for activity? A few. Skill. Yeah. Knowledge. And a few. Okay. So let's start off with knowledge. What does that mean, first of all? So it means for us, I guess, coding languages, like I know Java, I know JavaScript, I know PHP, I know HTML, I know whatever. Domain knowledge, so that means you're actually working somewhere and you know what the company does. So in our world, that's a newspaper. Maybe you understand media. And then past experiences. So, you move around and you grow and you learn things. And so you bring all of that knowledge with you somewhere else. So that, in my book, is knowledge. And that's easy to grow. Then we have skill. Now, you might have all of this knowledge. You might know JavaScript or Java or something, but that's pretty useless if you then don't go and put that into action. So good coding practices, knowing how to solve problems, because that's all we are as problem solvers. Deliver this requirement, find that bug and fix it, make this thing work better. All we are is problem solvers. So if you can't do that, your knowledge is not very useful. And I like to think of a focus on testing and quality, because why would we deliver something which then ends up being not very good? So I think skill is pretty important, and that's also easy to grow. But activity is the thing that I look at the most. So what is activity? Activity is just doing things, actually working. Your attitude. So what's your attitude to life? What's your attitude to work? What's your attitude to what you do day to day? What's your attitude to your team? How much of that do you put into practice? You've got all of this knowledge, you've got all of these skills. How much do you actually then take that and go, right, I'm actually going to go and do this? Because if you have all the knowledge in the world and all the skills and you sit at home, you're not much use to people. So actually getting out there and doing something about it. And what is your approach? How do you approach your work and your team? Have you got a good attitude or a bad attitude? Are you grumpy? Are you ambitious? Those things are really hard for me to change. It's a do-it-yourself world. If you have a good attitude, if you want to do all of these things, you can grow and you can become a superstar. But it's very, very hard for me to change that. So I see it that activity is by far and away the biggest part of the pie chart here. Skill is interesting, knowledge less so, because they can be grown out. And when I'm hiring, when I'm talking to people, when I'm managing people like Andy, that's what I look at the most. If you don't bring the attitude, if you don't bring the activity, if you don't actually go out and do these things, you're not going to go very far. So my advice to you is just to do those things. So some tips for how you can look at yourself and go, right, I'm going to make a change. Turn up on time. Aggravates me so much when people arrive at the office when they choose. No respect for their team at stand-up time. Just turn up late. They don't care. That really irritates me. You will not go very far if you do that. Have a can-do attitude. Sometimes people will ask you to do something. Sometimes take a risk and just say, yep, I can do that. And then work out later on how you can do it. If it ends up being impossible, go back and say, look, it's impossible. But otherwise, go, yep, I'll get that done. There are 3 things that people don't say enough of. I don't know is one that, again, irritates me. If somebody says to you, what's the status of that, or how do you do that, or how does that work, and you don't know, just say, I don't know. I will go and find out. Don't bluff. It's one of the worst things. I was wrong. Anybody here never made a mistake? Didn't think so. People make mistakes all the time. I make mistakes all of the time. Own up to it. Say, yep, I got it wrong. I'm really sorry. I won't do it again. Or here's how I'll prevent it happening again. I need help. I can think of plenty of times when I was a developer and you're sitting there at your laptop and you're coding away and you go, another 10 minutes at this problem and I know I can crack it. And like an hour later you're going, just another hour. 3 days later you're going, stand up and say, hey, I'm stuck. Can anybody help me? Can you have a look at this? Rub a duck, do whatever. Just admit you need help. Be a team player, not a rock star. Everyone wants to be a rock star developer. But actually, if you are a rock star developer, you'll be marched out of the building. Team players are far more productive, far more efficient. And if you really are that damn good as a rock star, spread the love, make other people around you a rock star. Be adaptable and keep learning. No one knows everything. You'll be thrown into things that you've never seen before. Kind of embrace it as you go look for it. Go, right, I want to do something new, something different. Be adaptable and embrace change. Teach and mentor. I look for people that can come into a team and be surrounded by juniors or even people more senior than them and teach and say, hey, I've seen something that I really thought was cool. Here's a website that I liked. Here's an article that I read. Or I looked at your code and it just strikes me if we did this thing a bit more differently, it would be better. So teach and mentor. Take juniors under your wing and make them grow. Because actually, if you take somebody under your wing and they become fantastic and they shoot off and become a star, it reflects well on you as well as it does on them. Practice good communication. We as developers don't always have the best communication skills, and that will hold you back. So practice good communication, practice talking to people, practice getting on your toes like this and talking to a crowd of people. Think about what you're going to say. Never lose sight of quality. You can get by writing shitty code without any tests for about 10 minutes, and then you'll be found out. So always make sure that you have good quality code. I would encourage TDD. It's a thing that I talk about all of the time when I'm interviewing people. Test first, you know it's absolutely right, you've met the requirements, and then you write your code. You'll write less code, you'll write it faster, and it'll be spot on. Do what you can, ask for more, and stretch yourself. Don't just turn up to work and do your jobs. Come into work, do what you have to do, then ask for more. Say, can I do something else? Can I try this? Can I try that? Stretch yourself. Go well beyond what you would otherwise do. Go out of your comfort zone and expose yourself to the risk of doing something new. And smile, please. I see a lot of grumpy developers who just sit there with their headphones on, really fed up with the world. They're really pissed off they've had to come to work. It's not nice to see. Please put a smile on. People will like you a lot more and you'll do better. So they're my thoughts on how you can improve yourselves, earn more money and go and get a better job. That's certainly what I look for when I'm hiring. So I'd like now to wrap up and hand over to Andy, who's now going to talk about React Native and GraphQL hard but awesome.
Cool. Thanks, Jeremy. Cool. Okay, so first things first, you've probably seen some of the Times newspapers kicking around in here. This is what our digital offering looks like today. So we've got the website up in the top left there. We've also got iPhone app, Android app, iPad app, actually different to the iPhone app today. Same with the Android tablet. We've also got Kindle and Kindle Fire. What this really means is that at the moment on our old tech stack, we've got a whole sort of mess of different code bases. If we want to make a change which has to be reflected across our whole portfolio, we have to make that change, well, 7 times. Well, actually, no, it's worse than that because behind these sit several different APIs. They're all tailored towards giving the right experience on web or the right experience on mobile. These different platforms all have different needs. So it might be more like 10 times or 12 times for certain features if we need to make them. Beyond that, if we are looking to the future of what we're working with, fragmentation of devices and platforms is only getting worse, and it's becoming a bigger and bigger problem. So here you can see this image is taken from OpenSignal is to display Android device fragmentation from 2015. You can see just the sheer amount of devices that are there. And as I say, that problem's going to increase, particularly when you start to think about other platforms such as like VR or smart speakers and that kind of thing. And who knows what the future will bring. So we're sat with this problem, which is that the world's kind of changing, and it's always changing, and it will continue to do so. We have all these sort of software engineers who are getting more and more specialized in their areas and kind of becoming tribal and looking after the new devices and platforms that are coming out. But there's not really enough to kind of go around. And it also means that every time we try to change something, we're having to put more and more and more effort in because consumers really expect and have high expectations for each of these platforms that we're supporting. On top of that, we have traditional APIs kind of struggling to serve such diverse needs. REST, in particular, like a typical REST API, has like a typical payload that it might serve. If just Alexa needs a particular bit of extra data, if we add it in there, that's all of a sudden it's out on web, it's out on Android. It's slowing other things down. So we end up with lots of repetition of effort, and ultimately it's kind of unsustainable. So we came around to our solution, which is to use React Native, web, as well, and GraphQL. So these are two technologies which are helping us with our goal of componentizing our architecture and allowing us to make a change in essentially once-ish and have that sort of propagate through all these different platforms to allow us to scale better from an engineering point of view. So just before I go into this, can I have a show of hands how many people have heard of GraphQL? Okay, pretty good. And React Native? React Native Web? Okay. React Native Web, not so many. Okay, so what is GraphQL? It's an open source specification for data querying and manipulation on an API. Initially developed by Facebook, it's been publicly released now. It's now got its own foundation. I think it's under Linux Foundation project. And it allows clients to ask for exactly what they need and nothing more. So you need to add a new field, you can just add it in. Clients are only asking for what they need, so only the Alexa app will ask for that particular field. And what you can sort of see at the bottom of this slide is, on the left-hand side is a query I've put together, which is just saying, I want an article with a particular ID. I'd like its ID, its headline, all its related articles, and I'll get their IDs and headlines too. So you can kind of nest these things, because obviously all those articles have related articles and so on and so forth. So you can get these really deeply nested queries and kind of ask for exactly what you want. And on the right-hand side is the response from our API. And I should say this is currently open to the world, so api.thetimes.co.uk. Something else which is worth noting here is that on a typical REST setup, you might need to do something like this. So you might need to make many requests. One just to get the article with their related, and then keep asking for all the related articles data. So you end up with quite a chatty interface. For mobile in particular, that's not great. Networks can be a bit tricky to work with. So this gets you everything you need in kind of one call, which is really handy and very powerful. React Native. So this is a JavaScript library for building components for native iOS and Android apps. It's based on the popular React web library and initially created by Facebook as well. So this allows us to build literally components. And I've pulled out a few examples here. We've got an author roundel there, some topic tags, and a paragraph. And what we do is that allows us to then compose larger items like full article pages or even a whole website / Android app / iOS app and so on from these particular components. So this is like a really simplified version of what our stack looks like, our new stack. What we've got on the left-hand side in red, sorry, it's not too clear on the projector, is like our backend services, our databases, loads of third-party services. We wrap all those up in a big single GraphQL API, known as the Times Public API, and that's the one which is on api.thetimes.co.uk. That allows clients to have this common interface to talk to all of these various microservices and everything else that's sat under the hood. Kind of gives us the best of both worlds. So rather than having clients having to understand all of these many different things, it can understand one thing and query it well, and then we can hide all of that complexity underneath. But that complexity gives us the ability to move quickly with typical microservice benefits. On the right-hand side, you see these are some of the examples of our clients. There are many more, but then the dark blue, again, not great on the screen, is Times Components, and that's our component library. This is the React Native bit. This is open source, so you can go to GitHub at NewsUK /Times-components and find everything we're building there. And also we have a storybook, which I'll come on to a bit later, sat at components.thetimes.co.uk. We are primarily, we're building this for ourselves, but we want the community to be able to use what we're doing. And also by building in the open, we're kind of holding ourselves to as high a standard as possible. So we believe in open source and we believe in building in the open. So these are two things. So our solution, in summary, componentized architecture. It's not write once, use everywhere, because typically we can't quite write it once and make it work on iOS and Android and web. There's a few places where we need to tweak things and specialize them for those particular platforms. But broadly speaking, we get an awful lot of reuse. And the co-location of those features is really important to us because then you can very easily see and maintain things when you need to make a change. We have a unified web layer, unified view layer, which is common across web and native. It's a little bit less common, I think, to use React Native Web to build a website, but that's what we're trying to do. We don't want to treat web as a special case. We want to treat it as just another platform. And that gives us easier feature parity, and our GraphQL API, it means it's client agnostic, so we can throw all of these various different specialist APIs away and just have one single API to rule them all. So, some of the challenges and interesting things about using this stack. We have naysayers, people who don't believe in what's going on. You typically see this more with native developers, not all, I should say, but some, who don't see how it can possibly work. There has been sort of well-publicized blog posts from Airbnb talking about why they've moved away from React Native. We've looked at that, and their reasons for moving away are not reasons why everyone should move away. It just wasn't working for them. We believe it will work for us, and our use case is quite different to theirs. So there's a few things like that, a few challenges that we need to sort of overcome, but broadly speaking, people can get on board. You tend to find the JavaScript people a bit more willing to go for this than the mobile, but yeah, it is what it is. We see a drop in performance using React Native. It's roughly around 10%. Now this is improving over time as React Native develops and becomes better. And for the vast majority of what we do, 10% performance loss is not a big deal. It doesn't really matter to us. It might matter to your projects. It depends exactly what you need to do. What our approach has been is to say, okay, when we hit something, we say the performance in this area is not good enough. We'll do everything we can to optimize the React Native. And if it's not possible to get it any faster or better in that set, then we may move back to native just for that sort of key piece. But what we do see is a reusability or code reuse of about 70%, which is huge. Like, we're getting such massive reuse and massive gains just for a small penalty on performance. Some of the other things, tooling and the community in general, it's still fairly immature. So expect to hit problems, expect to be the first to find problems, and sometimes the community is not the most helpful at sort of allowing us to help them. So, for example, there's a React community SVG library we were using, and we found that it was fine when you were only using a few SVGs on devices. As soon as we had a big list with loads and loads of them in, the performance kind of sucked. It was a bit buggy. It wasn't up to our standards. We did try and help and sort of fix that library, but we weren't really getting too far with it. So in the end, unfortunately, we had to sort of pull and build our own. But we built our own, and it is now open source. And that's been built with like our experts in iOS and Android. So that's now sort of back in the community, if you like. The other thing is documentation. Sometimes is really good, and sometimes a little lacking. So you have to just sort of take it with a slight pinch of salt and kind of know what you're getting into. The particular case which really bit us early on was the way React Native talks about spinning up a hybrid app, which is what we've got. The workflow is not brilliant. It's probably okay if you've got a team of like 2 people, 3 people. Once we've got an Android set of like essentially a team running alongside React Native components and we're trying to build all this stuff, we're finding it kept tripping over each other. So we've had to come up with our own workflow. And the way we kind of got around this was to have our React Native stuff build an Android bundle and then use Maven to pull that in and sort of have a normal build process for Android as far as the Android side of things is concerned. And that has completely decoupled the two, which is awesome because it now means we don't have any build problems. And we're doing the same thing with iOS, so the same kind of thing. Something else we should mention about the Times app is that it's offline first. So when you load it up, it's not like it's constantly online and getting data. It's already pre-downloaded it effectively and gives you an edition, much like a newspaper. What we found was that we had Apollo living in, Apollo's a React Native client server implementation. So we had Apollo client sat in the JavaScript implementation, sat in React Native, and we had Apollo client native implementation sat in native. And sort of early on we said, okay, well, why don't we just sort of, that's got all the data in it in native world, we'll just sort of reach across and grab the data and use it in React Native world. That doesn't work, don't do that. Those cache implementations work completely differently. And those two libraries, whilst they work independently, are just not, they don't play nice. So what we kind of learned was that we won't pull data from the native world, but instead we'll push data from the native world into React Native. So essentially we're doing all the networking and everything in native, and then we push all that data into the React Native view layer, and then it can render. So what this has really done is sort of solidify this idea that we're just using React Native for our view layer and nothing more. And so you can kind of think of it as like a JSON to pretty like view converter. We do actually still have some limited networking in online-only components. Like you get to the bottom of our article, you can pull up comments, and they're completely online-only. So we just let the React Native world deal with that. Text views. So here's another interesting example. So we needed superscript and subscript support, just so that we all know what that means. The top one there on the right-hand side, that's subscript, as in the 2 is a subscript, and the one underneath it is superscript, where you raise the 2 to the top. For our newspaper, we needed this support, and React Native does not have that support out of the box. So we thought, okay, great, it doesn't work. We'll write our own component, and we'll base it on the text views that React Native gives us. That didn't really work either. The React Native's implementation of text views is really mysterious and complex. And so because that was so difficult, what we actually ended up doing in the end was we found that there's some ASCII characters which basically give us the numbers in superscript and the numbers in subscript. So we just use ASCII characters instead. It's a massive hack, but it does work well. And because we only ever need numbers, it works for us. Another thing around text views is that until recently, like letter spacing and line height styling were not really well supported, particularly on Android. And for us, like typing is a really important thing as a newspaper. So this was challenging. We had to put a whole bunch of hacks in there to like get the spacing right and things like that. But actually, it's all been fixed now, so we could take all the hacks out. And this is just kind of part of the process of being on an ever-maturing system, is that this is going to happen from time to time. To be honest, things like this probably don't matter to most use cases. It's just that being a newspaper really mattered to us, and it wouldn't have flown with editorial. React Native Web is an interesting one. So there's a little bit of kind of mind bending required here. So if you're coming from being a web dev and then you want to write some web React, except actually you're writing it in React Native, you're using native components to describe the web, which is a bit odd. But then that gets converted back to web afterwards. So you're kind of going web, native, web every time you want to like understand what you're building. Get used to it after a while, but it is a bit of a sort of a roundabout way of doing things. The other thing is, like, by default, React Native Web just spits out divs everywhere. Like there's no like paragraphs, there's no H1 tags, like it's just divs. And what that means, like from a visibility point of view, like you're looking at it on a browser, it kind of makes no difference. But if you're trying to use like screen readers or accessibility or any kind of other things, that doesn't really work. This has got better recently. They've now added a lot more accessibility options into React Native Web, so we can kind of do a lot of the stuff that we wanted to do. But again, this has been quite interesting to try and sort out. And sometimes we have to break out to get web support. So as I was saying earlier, we don't always write once use everywhere. Certain things like flat lists are excellent and allow you to do big scrolling lists on native, but as soon as you need to try and do that on web, they're not really supported. So instead we have to have like a web specialist class for a particular component, and same for CSS breakpoints. They're sort of very web specialist things. So what we tend to do is we'll build a base class which has most of the components functionality and everything else in it, and then have a separate class for web so that we can actually render it to the web properly. GraphQL, our experience with that, few things. So sort of less well understood than most APIs that are kicking around these days. It's a bit more complex for a client to use, but with a bit of teaching, we get there, and it's fine. And actually, people really like it once they get to use it. But just to say that, like, we're opening this up to a lot of people, and then we get a lot of questions about how to use it. Security and robustness are another thing which are a challenge that we're currently solving. This is the idea that I mentioned earlier, that you can nest queries. So you have an article which has related articles, which has related articles, and you can construct like this huge nested query, which would just be like phenomenally complex for the server to resolve, and could potentially take like hours or days or whatever. These kinds of things are basically an attack on a GraphQL API. So what we're doing is we're putting in query complexity analysis. So it actually looks at the query that's been handed to it by the client in the first place, and then says, okay, how hard is this going to be to actually render, or for us to go and get this data? And if it's too hard, it just says, no, sorry, you need to be under a certain score. We also have caching is a bit more interesting than using a typical REST API. With most REST APIs, you can basically just kind of slap a HTTP cache in front of it and it'll scale for days. Because GraphQL is just lots and lots of different queries and every client is going to query slightly differently, it means that this whole thing is a little more complex. You don't get quite the same cache hits that you would normally get, and it means that you tend to end up pulling cache layers into different parts of the system to make that work nicely. Entirely possible though, it's not completely out of the realms. Some things which are absolutely awesome about it though, the self-documentation of GraphQL. When you're looking at those schema documents and you can see what's going on, so you can sort of say, I want an article with this, that, and the other. That's all built into the language. So any client can come along and just read through the docs. I have realized that I actually wanted to demonstrate this. So I'm going to see if I can do this quickly now. Oh, no, I'm not going to be able to because it's not my laptop. Forget that. Sorry. And then, and then it's strongly typed. So all the way through, every field has a type, and that allows clients to make much more strong assumptions about what's going on. You can say if it's nullable or not, and you can create your own types, which is brilliant. Another kind of interesting thing we had was around DropCaps. I think this is very specific to like what we do in publishing, but an interesting problem nonetheless that we solved. A DropCap is the big T here, where you sort of get the first capital letter of an article kind of spans over 3 lines, and then everything wraps around it. This is like really simple to do in web. It's just a bit of CSS. In native, when we had to build this the first time around, this was really, really difficult to get right. It sounds so simple, but getting text to flow around these things in native land is just really challenging. And what we found was actually when we were using React Native, this was easier. We had to do a bit of an interesting take on it though to make it work. So we use this library, React Native Text Size, and what that does is it allows you to figure out where lines are going to break and go around. And then what we do is we put the T in as a separate item, a separate view. Then we start to build the next paragraph, and we build that out and use the React Native Text Size to figure out where the breakpoint is, where that last line break is going to happen. Then we chop that paragraph down, and then we generate the rest of the paragraph underneath. So you end up with these 3 separate elements, which kind of wraps it around and makes it look pretty. Surprisingly complicated for something which looks really trivial on the face of things. Another thing, tooling and developer experience. So Storybook, I was mentioning before, is a fantastic tool. And I think this is another Facebook one, but actually I'm not too sure about this. But this allows you to kind of live look at your components, which I'll show you in a sec. The whole thing around React Native or React, it's not really a feature of the tool or the framework as such, but it allows us to do this whole component-first architecture, which is hugely, hugely powerful. People can work on these tiny little things in isolation, test them in isolation, do visual regression in isolation, and do all this great stuff and make sure these things are absolutely bulletproof, and then later compose them together. And because of that, it has this really nice feature of everything just having its own little space, and you don't ever sort of tread on people's toes. You also get this really fast iteration. You can hot reload these things, so you can have a device running on your desk, and you can be looking at what you're building, and you change some lines of code, and you see it change on your device. Like that's worlds away faster than like the typical way you'd be working in native land, where you're having to rebuild, and that takes minimum like 20-30 seconds, worse minutes every time you want to see something change. So it's like a whole way of actually iterating much more quickly when you're building things. And the last thing is shipping to NPM. Because we've open sourced all this, we can essentially say to anyone, okay, yeah, go and use our components. And we have people around the company who just pull it in via the standard NPM route, and they've got hold of everything they need. So you want to build a new product, yeah, just grab these components, slap them together the way you want, and away you go. It's fantastic. So I'll just see if I can show you components. Oh, sorry. It was there. Why does it keep going away? I can't type on your keyboard. Sorry. Okay, so it's really fast. That's the first thing to note. When you realize you should have preloaded something before you started talking. Okay. Oh, okay. Here we go. So these are all our primitives, and again, this is just live on the open web. So these are just small things. What you're seeing on the sort of top right of the screen is like the actual component itself. See if I can find some more interesting ones. So if we look at like a paragraph with a drop cap, that's what I was talking about before. So these are the components that we can use, and you can kind of actually alter these in real time and change some of the ways they're rendered. I was not really showing very much, but I'll see if I can find something a bit better. And then later on, once you actually like compose all these things together, you can actually take all those various little tiny components and produce like a whole component, which in this case is an article page for us. And you can see, let's see if I can, there we go. So the way it's all laid out, we have like adverts in there, test headlines. This is using the latest version of our components code. And as well as being able to see how all this works by just looking at it like that, you can go and play with these various things. So say I wanted to take the headline away, okay, or labels, so you can see the label changing there. Get rid of the lead asset, so that's the image is gone. So all of these different props you can just change on the fly in Storybook. It's a fantastic tool. Really, really good when you're trying to develop and see what's going on. The other thing is some of the internal tooling we've done. Oh, sorry, I'll actually show that on there. So Storybook is Storybook/Storybook on GitHub. We've developed a whole bunch of internal tooling ourselves, which is all open source again. Fructose, Dextrose, and iSpy. Together, these give us visual regression testing. And what that means is, this is iSpy, which is the web one. What this does is it has a snapshot, like basically a screenshot of what something looks like today. And then it has the latest, which is the one in the middle, which says, okay, this is now a new snapshot of what's going on. And then on the right-hand side, it gives you the differences. And what it does is it highlights the differences in pink, which you can just about see at the bottom right. And it also will then give us some indication on our automated tests. So in our pipeline, something might fail if it's unexpected changes. So if anything is moved by a pixel, you might not be able to see it by just looking at it, but this thing will show it up, and it means that we can make sure that we have no regressions in everything we do. So, in summary, React Native, GraphQL, both fairly new-ish technologies, still growing, React Native in particular, comes with a lot of challenges, but what's life without challenges? These things are really, really good things to get into, get your teeth stuck into, and work with. And they have so many benefits, and we just keep finding more and more as we're working, and finding nicer ways to do things, and then just trying to feed back to the community. And it's nice to be a part of something like that as well. I should say, as Jeremy mentioned, we're about 18 months into this process of sort of building out this stack. We've still got at least 6 months left to go to actually build all this stuff out, which means we're still finding those challenges and still getting to grips with them. But it's what makes life interesting. So the other thing I'd like to say is that I know it's very easy for developers to find themselves in particular tribes. So it's like, I'm a back-end JavaScript engineer, or I'm an iOS native developer, or whatever it is. What's quite nice about this tech stack, actually it kind of forces people to leave that area and start to work in areas that they're not as used to and perhaps not so comfortable in. And it also means we get this cross-pollination of ideas. And all that is really doing is just making us all better engineers. So I think that's where, how I like to see it anyway. I think it's very good. So thanks very much, and I'll now hand you over to Jem. I'll take that.
Oh. So good evening. Yep, I'm Jem. I don't work for the Times at the moment. I work for NewsUK, of course, but I work on the other side, the other publication, that's The Sun, and we have a loyalty program called Sun Savers. What I'm here to talk about is something I've entitled Ephemeral Systems. I just felt I wanted a snappier title than to talk to you about continuous integration and continuous deployment. But actually, that's really what it is that we're on about. May I ask, who's actually been involved in releasing their product? So you've done months and months of development, weeks and weeks if it's in, but who's actually gone through that day, that evening where something is made live? And sometimes it can be a bit of an experience when things don't quite go to plan. I think if we take our continuous integration and continuous deployment, these practices and principles that we've adopted, they really help make sure that release is assured and successful. Is it spacebar?
Yeah.
It does. So why have an ephemeral system? Well, what do I mean by it for a start? It's ephemeral means short-lived. Well, short is for the readers to make their own explanation. Compared to systems of old, what we're talking about here is that a system can be completely rebuilt from scratch. This does not mean that we have some infrastructure that's been running with an older version of the base operating system, for example. Each time we do a deployment, we're starting from afresh. All changes, regardless of what you're doing, we are going to make a new release. And this is something that really changes the mindset. So there's no more about updating a particular configuration in the live system. If you want to make that configuration change, you change a configuration file that's part of the deployment and we re-release. It doesn't last very long. Immutable. The infrastructure that we're deploying when we make that release is immutable, by which I mean it is the same as it has been from when it was deployed onto your local laptop or onto your integration environment where you're running your tests. The pattern for this is that essentially a system is seen as data, which of course can change as the system is used, and everything else. Everything else is refreshed each time you deploy. This is one of the mantras. So some of the principles that we employ for CI/CD. The deployment must be repeatable. So it seems an obvious thing, I think, in these days, but so often we got used to releasing code. It would iterate over test development and test, and certain things would only be done once, and then we would re-release, and the initial change that we made with that release got long forgotten. So that when you came to release it onto production, of course, that very important step, which was not captured as code, was missed, and then your evening of release did not go very well. So we automate everything. We try to automate everything down to bare metal, by which we mean the machines themselves, the configuration, it's cloud-based. We use AWS at the moment. We script from everything from the VPC all the way down to the machines and the queues that are being used in the system. Principle, if it's difficult to do, then you should do it often. Don't just leave it once and think, thank God that's over, because In this world, you're going to hit it again and again. And the more often you do something, the less painful it becomes. Everything is source code. Everything as code. If you can script it, then that is what we should do. This assures that you script it the once, you deploy it many times. Done, the definition of done. It's certainly not that I've released my code, I've checked it in, it's now over to some tester. Nope, done in our world means it's released. If it's not released, it's not being consumed by a customer, it's as good as not done. Build quality in. So our deployment pipelines that we have, they're there. One of the reasons that they're there is to test things in a similar fashion. Each and every change has the same regression pack that runs over it. This ensures, as Andrew showed with his visual regression, that we pick up any differences between release. Everyone's got a responsibility for it. So as developers, you check things in, you may leave it to the testing community, and it becomes the tester's responsibility to make sure that it's top quality. A principle we like to stick to is that that's not the case at all, it's the entire team. And of course, we would like to improve continuously. There's a problem with that, we fix, we iterate and improve. So, our artifacts, we like to build them once and once only, and then we promote it many times. The differences between environments are configuration. The configuration is held centrally. So the artifact that you're actually building is the same, again, regardless of whether you're on your laptop and developing it locally or whether it's live. So the chances of there being differences that are going to cause a problem are minimal. Use exactly the same mechanism. Again, we like to come up with these artifacts, but then we find that it's all too easy to deploy them differently, depending on whether you're in that systems integration environment or whether you're UAT or ultimately in live. Run exactly the same steps. Your release process is what's being tested just as much as your code. Each time you deploy onto another environment, we should have a nice thin set of tests that the term we use is to smoke test that deployment, just to make sure that everything is as it should be. The organizational policy, so what do I mean by that? That is basically on about checkpoints along the way. So we might have an organization that would simply allow you to check a change in, it goes through automated tests, we make it live. We live in a world where we like to go through a user acceptance test, so one of our organizational policies is to actually sort of stop the line when it hits UAT. Once everybody's happy, we would then release that through to live. So we do have a manual stop. Anything fails in your pipeline, stop. There's pointless going on. You can have parallel executions, of course, but once you hit a problem, then the pipeline should stop. And then you should fix the problem and start over again. So this is a little diagram that I've got showing this. We build it once there. We deploy through to our test environment. Results are back to the developers. And on we go. The same deployment is pushed onto staging. And then I've put in there, that's one of these organizational checks. The manual deployment into production, we prefer that to happen under change control. Somebody actually presses the button manually. We're live. With our pipelines, we've tried to avoid vendor lock-in. We talk a lot about making things cloud agnostic nowadays. So whilst it might appear that we're rather locked into HashiCorp here, we're trying to make ourselves agnostic from the cloud. So previously we were doing a lot of things with the AWS toolset. Nowadays, if we can use Terraform rather than CloudFormation, then that will be the choice we make. Jenkins happens to be the pipeline software that we use, and HashiCorp Vault is where we're keeping our secrets and managing those. So, in summary, everything as code should lead to successful deployments. Thank you.
Well, thank you, Jem and Andy. Now I'll open up and ask anybody if they have any questions for any of us. We'll try and help.
buzzing with questions.
Yeah.
Or alternatively, you can just grab a beer and
Yeah, absolutely. There are beers, whatever. Just feel free to ask us. But I would remind you, we are hiring Sofia. This is why the three of us are here. We're doing interviews. We're starting some teams here. We have a whole raft of people that we would like to hire. So if you're interested in leaving where you are and coming here, please grab us or talk to Questers recruitment team. There's an email address there. If you're not able to talk to us tonight, then give an email. We'll be coming over quite regularly. We'd love to meet you. We'd love to talk to you and find out if we can do it together. So thank you very much indeed for listening to us. Please grab a beer and I hope to catch you later. Thank you.